My name is Pooja. I've spoken to many of you before. I'm meeting some of you for the first time. It's very nice to meet you. My talk today is going to be about the role of geospatial data for risk management in a changing Arctic. I'll try to keep it within 15 minutes. It might go a couple of minutes over because I always have too much to talk about. But let's see how well I do on time. I think the AOS has historically done a really good job of bringing together a variety of stakeholders, academia, citizen groups, nonprofit organizations, public sector. But I'd really like to thank you for opening up the dialogue also to the private sector. So I represent FUGRO, which is the world's leading geodata specialist, as well as the WGIC, which is a nonprofit trade association of private companies working in the geospatial and Earth observation sectors. If you listened to the talks this morning, you probably heard Barbara Ryan giving, I think, a really good introduction of what the WGIC does. So I'll start by summarizing the challenges for. You guys able to hear me in the room?
Yeah, you got stuck for a second.
You're back.
You're back.
Oh, perfect. So I actually spent a year living in the Arctic in a town in northern Sweden called Kiruna. It's a town where ground subsidence was a real issue. So much so that they are actually moving the city, the town center, house by house to a different location. So the Arctic has always had a very special place in my heart. But none of the challenges I'm showing you here are probably news to you guys, being experts in the Arctic domain. But these statistics were quite an eye-opener to me. There are about 5 million people living in the Arctic permafrost, where there are at least 120,000 buildings, 40,000 kilometers of roads, 9,500 kilometers of pipelines. 70% of this infrastructure and up to 50% of critical infrastructure is at high risk of damage by 2050. And I believe the projected costs are up to tens of billions of dollars. We've also heard today and in other sessions as well that the Arctic region is warming more than twice as fast as the global average. I've also seen numbers like 3x and 4x in literature, but honestly, even twice is scary enough. The Arctic coastlines have been eroding at nearly 0.5 meter per year over the last half century. So that's about 25 meters in total on average, which is an enormous amount. And these trends are unfortunately expected to continue for the foreseeable future. So our planet is obviously a very complex and dynamic system. It's constantly moving, constantly changing. And now particularly the Arctic region is undergoing a drastic change, which makes building and maintaining infrastructure extremely difficult. You've probably seen this recent paper by Hjort and others. It was quite a landmark paper in Nature. It gives us really a stark reminder of how Arctic infrastructure is expected to be affected in the next 30 years. I mean, that's when my daughters are going to be my age. That's actually really, it's not so far in the future. It's a really scary prospect. So the risk to natural and built assets mainly arises from what's called epistemic uncertainty. So essentially, it's the lack of knowledge or information that contributes to this risk. And if this is not effectively managed, it can have negative consequences. So by first identifying and then reducing this uncertainty, the risk can be better managed. This requires the acquisition and analysis of the right geodata at the right time to be able to provide insights to decision makers. What is the most important, though, is having a deep understanding of stakeholder objectives. That's what really helps in effective risk management. An example stakeholders would be policymakers and planners who prioritize strategic effort in a spatial sense, insurers who manage underwriting risk, but you're also talking about CapEx, OpEx, schedule, indemnity risks for asset developers, designers, constructors, and operators. So it's a whole spectrum of stakeholders who would be relevant to this sort of risk-based approach. So we as trusted geodata specialists, both for the government and for industry, we focus on two key kinds of challenges. So coastal hazards and infrastructure hazards. And this is where we believe that the private sector can really play a key role. So in the remainder of my presentation, I'll focus on these two solutions to these two main topics. So what about coastal hazards? So flooding, erosion, landslides, all of those impact our natural and built environment, our lives and our activities on the coasts. Land and public works managers rely on coastal geodata, and by that we mean, nearshore bathymetry, which is basically water depth information, imagery, topography, 3D models, hydrology, vector shorelines, all kinds of geodata to understand impacts to legal and geographic boundaries, resource ownership, and not in the least, public safety. Coastal mapping data are critical for several reasons, which include informed management of coastal lands and safe navigation in an ice-diminished Arctic. But of course, for us, as the folks who actually acquire and analyze the data, the Arctic coastal zone is a very challenging area to work in. It can be remote, it can be cold, it can be shallow, dangerous, and inefficient for a big marine ship, but also inaccessible for traditional land survey. So this leaves what's often called a white ribbon data gap in the coastline on our maps. So we really need to have fit for purpose tools to access these areas that are busiest in terms of use, and yet the most challenging to acquire from a geodata perspective. So in the 1990s, we commercialized what's called airborne lidar bathymetry, which is a technique which is an alternative to sending these heavy ships out there. You basically put sensors on an aircraft, a laser on an aircraft, instead of using sonar on a vessel. Now, in the 1990s, it looked like the picture on the left. You can see, if you look carefully, there's a girl sitting in that picture, and that was the amount of equipment you needed to, put into a massive plane to be able to capture this data. And now it's all condensed into this little red circle that you see that you can install, on a small plane or a big drone. So this is what we call our RAM system, and this can easily be installed on any small aircraft or on a drone. So for optically clear waters, it is a much safer, faster, and greener alternative to define the shoreline and shallow water depths. We've made similar innovations on the land side, so for topographic mapping. And this means that we now have a very efficient approach to map both the shallow water, the coastline, and the coast itself in 3D. So to give us that really seamless land-sea interface. So advances in technology and innovation in this case have definitely helped us in addressing what I mentioned before, the white ribbon data gap, which is exactly along the coastlines where we want the information. This sort of technology has been able to assist in solving this issue in a very effective way. So the other thing that is still very much vessel dependent is in deep waters. In deep waters, you do need vessel-based heavy ships. It is really still the main method for hydrographic and ocean floor mapping. But what we have been seeing in the recent years is the development of uncrewed surface vessels, which are basically aquatic drones, if you want to call them that. They are used alongside a traditional survey vessel, and you use it as a force multiplier. So this makes data acquisition up to 50% more efficient, and up to 90% less greenhouse gas emitting. So win-win. Another development that I think can be very much applicable to the Arctic is remote operation centers. These allow experts to control the equipment and the vessels, not within the hazardous offshore environment, but from the safety of an onshore environment. So you're basically transferring personnel from a ship into an onshore environment where they can do all the controlling remotely. Satellite imagery is the other aspect where I think for the Arctic this is an extremely important geodata source. It's used in this context of coastal mapping for reconnaissance, for de-risking and optimizing coastal surveys. If you look at the picture in the center, you'll see changes of a small island over years. Satellite-derived products really help us assess coastal dynamics over time and detect these changes and hazards. It also helps us in verifying old navigational charts. You'll see in this picture in the Unimak Island in Alaska, you'll see that satellite imagery has really shown us that the navigational charts that they were using are actually fairly outdated, in fact, very much outdated. So yeah, we have a whole toolbox of technologies we can use, right? Integrating all of these different data types collected with a whole range of different sensors is an art in itself. Each sensor has advantages, limitations. Integrating them not only improves the data quality, but also reduces data voids. A fit-for-purpose solution is one that really balances data quality, cost, schedule, and safety constraints. And this requires collaboration, both within the private sector and among all the relevant stakeholders. A good understanding of stakeholder requirements is key, and of course, technical expertise to know exactly which technology to use where for answering which questions. So the next topic I'd like to move on to is the impact of permafrost degradation on infrastructure and on our foundations. Building in regions of continuous and discontinuous permafrost presents serious and unique challenges. But these are not new challenges. I mean, we've been building on permafrost for centuries, right? It's the rate of environmental change that now makes these issues more and more urgent and more acute. How we address these challenges determines the integrity and longevity of Arctic assets and the quality of life for people who live and work there at a very basic level. So permafrost geotechnical investigations are done using a technique that's called frozen soil CPT, cone penetration testing. This is quite an exciting innovation because we can reduce the number of drilled boreholes to actually measure permafrost depth. So a lot of data can be acquired in a single push performed within a single working day. So you can imagine the Arctic, where infrastructure is sparse and the work season can just be a few precious weeks in the summer. If you have something that's smaller, lighter, and faster, it makes a huge difference. Permafrost is a subsurface phenomenon. It cannot be directly observed from satellites, but its impact on the surface can be measured using remote sensing methods. So SAR satellites in particular are especially useful in the Arctic because SAR imaging is independent of solar and weather conditions. INSAR, interferometric synthetic aperture radar, is therefore complementary to the more accurate and in situ measurements that I showed you in the previous slide. And together, this wide area coarse resolution mapping, together with the more precise in situ measurements, can provide deeper insights into changes in permafrost conditions. So countrywide INSAR deformation maps are now available. On the left, you see a snapshot of Norway. On the right, you see a snapshot of Kiruna in Sweden. Hopefully there will be more and more such open data available, also through the European Ground Motion Service, where this data is publicly available to decision makers and citizens, of course. The other topic I want to talk to you about is about road infrastructure. So permafrost is treated as a stable base on which roads are built, but as temperatures rise, the permafrost is melting and at differential rates. So the flexible asphalt surface is no longer firmly supported, which means that it can crack and slump and heave. And if it's in a really severe situation, you can fall into a sinkhole. So the Alaska Department of Transportation, the DOT, was concerned about locations of unstable permafrost and wanted to review their entire road network to really accurately quantify the areas that experience damage. You actually see an example of a damaged road in this picture. So about 18,000 lane kilometers were a specialized vehicle called the Automatic Road Analyzer, ARAN. During Alaska's short summer season, these vehicles were driven at highway speeds or near highway speeds across the entire road network. And the multi-year analysis monitors the rate of change as well, so measuring the impacts of thermal degradation over time. These data are web accessible to the Alaska DOT engineers on demand, and they provide input to solutions that prevent or delay thermal degradation of road infrastructure. Now, this data is collected to support the maintenance of roads, but it does a huge database of data. And in future, you could imagine this data being used also for, self-driving cars or, multiple other technologies. So, we've seen this picture from earlier today, and I really love this picture. The talk so far has been quite technical. Geo-data is useful. It's only useful if it can be converted into information that can be acted upon by citizens and decision makers. So it's all about simplifying the complex. So I'll show you an example of how all that complex geodata can be really presented in an intuitive way. This is not in the Arctic, as you may have figured, but this is technology that can be widely applicable over any area, really. So some aspects to really keep in mind to have this intuitive GIS interface that, just the common average citizen, non-technical audience can understand is, well, first of all, you need to really educate end users on accuracy and uncertainties, especially when you're talking about forecasts, and you need to make it, you need to make the data credible. Geo-data must be able to work across multiple platforms. You need to really look for solutions that utilize open standards. Geo-data can be huge. You're talking about terabytes and terabytes and petabytes of data. It's cumbersome and hard to manage. So moving to the cloud and making them easily accessible is paramount to a useful geo-data program. And lastly, we need to pay attention to security. Even though one would want geo-data to be as free and open as possible, data rights and licensing considerations will need to be considered. Robust user management, credentials, encryption processes, all of that is really important to ensure that the data remains in the right hands. Data sharing, we talked about that quite a lot, particularly in the private sector, is really key to creating value from geodata. So examples we've heard over yesterday and today is the seabed 2030 initiative, the UN Decade for Ocean Science, NOAA's Seascape Alaska. We try to lead and shape private sector participation in these data sharing initiatives. So we provide high resolution bathymetry, so the sea depth information that I told you about. We collect that during vessel transit. Ships are moving from one project to the next. We just turn on the machines and make sure that they just collect the data on the way. And we contribute that for free to the seabed 2030. And our contribution is reached up to, I think, 2 million square kilometers, which is about the size of Mexico. Just putting things in perspective. We've also accepted an invitation from the IOC UNESCO to join the Ocean Decade Alliance. This includes an in-kind support via the loan of experts into the IOC Secretariat in Paris for establishing and administering 2 key ocean science working groups. One is around a digital ecosystem to share, manage, and distribute open ocean data, as well as equitable mechanisms to accelerate public access to privately held data. Another example of such an initiative applied to Alaska is recently we donated more than 1,500 kilometers of seafloor data that we collected for a completely different project for a broadband company called Quintillion. They installed subsea fiber optics in northwestern Alaska, and because we acquired the data anyway, we've just donated that to NOAA, and this is part of the US navigation charts now. And through efforts like this, we're also trying to really encourage other private data holders to share and disseminate their data for Arctic use. So that brings me to my last part, really, which is the call to action. If I were to summarize the talk that I've given so far, it's really about reducing uncertainty delivers better risk management, and this sort of risk management will need to be founded on robust, reliable, relevant, and timely geodata. There is no single magic tool to address all the constraints of acquiring the right geodata in the Arctic, and we therefore have to have collaboration and expertise. We need to have proper geodata management and liberation frameworks, self-service analytics, etc., so that non-technical end users can really grasp the value of all this geoinformation. And we need to incentivize data sharing across sectors and unlock data archives. This fits very well with FUGRO's purpose, which is creating a safe and livable world together. And I don't need to say anything more about the WGIC, motto or motivators, because I think Barbara did a wonderful job this morning, really telling us about the contributions that the WGIC is making across the board. But what I will end with is a statement that Barb made when we were, drafting the white paper. That's what I'll close off with, really. This talk has hopefully shown that advances in data acquisition, storage, innovations, all of this, cool stuff that we do. It's continually emerging, and innovations will keep happening. And they often arise from the private sector, given our flexibility, access to talent, and speed to market. And I hope that through this effort, the private sector capabilities can really be leveraged to the greatest extent possible for the betterment of the Arctic. Both as WGIC and FUGRO, we are committed to ensuring that the most up-to-date technologies and services are understood, accessible, and utilized to address the Arctic's changing environment. I'll leave you with that.
Oh, that was great, Pooja. So I think we should have some discussion now before we move on, if that's okay with everybody. Because I have a couple of questions, actually.
Please.
And I wanted to ask you about the road data, the haul road data for Alaska.
Yeah.
When did you start collecting that data, and how often? I guess DOT is running that program now.
Yeah, the DOT is running the program. I think we started collecting for them in 2017.
Yeah.
And it's really a yearly recurring thing. We acquire the same data every year. So we have that baseline to also study changes and trends in the road network.
Yeah, it's interesting because I worked up there one
Okay.
summer, and I drove that road from Fairbanks up to past Adigan Pass 8 times in 8 weeks. And every single time I drove it, the road was different. And so it's just got me thinking about it. And sometimes seriously different. Like one time I went to go out back to Fairbanks, and a mudslide had taken out a chunk of the road and the bridge. And it's got me thinking about the need for almost in those kinds of places, almost near real-time data. And so I was wondering how often the DOT actually collects that data to maintain it. But I think it gets flown a fair bit too. I don't know, Harry. Yeah, that's really interesting. Okay, so that was my question. Does anybody have any?
On the road piece again, a DOT supporting, I wonder how flexible the funding is with regards to actually doing road maintenance, because for example in the Yukon, every road section is up for either kind of renewal or maintenance on a 5-year kind of rotating cycle. So what tends to happen is that a piece of road that looks fairly decent is nevertheless done because it's at its 5-year kind of point. And so with almost real-time data, or certainly seasonal data, which is quite flexible, I wonder how flexible the funding there is to kind of attend to maintenance, or whether it is the maintenance schedule is rigid even though there's lots of data.
I think this is a really good question. I'll have to check with my colleagues who actually speak to the DOT, and maybe I can get back to you with a more informed answer.
Thank you.
Anna?
Good morning, Pooja. Good afternoon. That was very intriguing. Your talk is like very overlapping with my research, so it's very exciting. Thank you so much for sharing it. One quick question. I was also reading your paper. So far, the challenges that what we are experiencing is we still strongly rely on lab work, right? So, like when you're showing the CPT and the remote sensing information and non-destructive geophysics information, we still need to, we still have that challenge. And just like your personal opinion, because so far I have to rely on pure geotechnical laboratory data for every single, in order to really identify how much ice content is in soil. In order to do like a geotechnical analysis, I still cannot fully rely on non-intrusive geophysics and SAR and other ones. Like, are you moving away from lab, or is it new innovation? Because even to do like electrical conductivity, for example, resistivity, right? I read a lot of papers that say, oh, okay, we're just using electrical resistivity, non-intrusive, but in reality, we still have to calibrate electrical resistivity to the actual physical laboratory results, right? We cannot just like drive a car with electric, like a ground penetrating radar and say, oh, it's all good. We still rely on a core samples, right? Are you guys using it, or you're just, because that's where uncertainty comes in, right? Like we cannot, based on our understanding, we still cannot use fully non-intrusive results without really doing core samples.
Yeah. So I think that, so I'm not an expert in CPTs at all, but from my discussions with my colleagues, I understand that basically every case is different, right? And there are some cases where, you know, you just use one of these CPTs and you drill a hole to a certain depth, and that kind of gives you enough information that you don't need to really, you know, cross-check it with a, so this is an operational technique. We use it in our operational project. So it's not like an innovation that needs to be, you know, still validated or anything like that. And we've been doing this for years. But I know that there are also some cases where, you know, you drill a hole and, you know, you get conflicting messages from that sample, and you need to maybe do a couple of other holes to confirm your hypothesis and so on. So yeah, it's not always like a single hole gives you all the answers, of course. But I'm quite certain that this is at a technology maturity where you don't need to really corroborate every sample with a lab reading and do that sort of testing. You might need to use additional techniques if you get an ambiguous, you know, result from your measurements. But to my knowledge, at least in all the case studies I've seen, it's quite conclusive. Yeah.
Thank you very much. This is very exciting. Definitely much less expensive than flying the core samples to you know, the actual cold room in the laboratories. Thank you very much.
I'd love to get in touch with you one-on-one, like if you want to drop me a line or whatever.
Absolutely. Thank you very much, Pooja. Appreciate it. Thank you.
Hazel?
Hi. Sorry, I forgot I wasn't supposed to unmute. I'm so used to being on Zoom and unmuting myself when I'm speaking. Yeah, thank you so much for your talk. This is Hazel. Just for folks in the room, I heard from people who were on Zoom yesterday that it helps if you say who you are, especially if you don't turn your camera on, because like the camera view of our room is really hard to read. So just that note. And then I have one quick question for you, which is just hoping that you caught the whole Arctic talk this morning. I forget, Leslie, I think was the name of, no, that was someone else. Now I'm all confused, but the talk about, it was Leslie, just about mapping near coast areas and more turbid waters, and that's been really relevant for Alaska, I know. And so just if you didn't catch that speech, would recommend that you all connect is all. And then, yeah.
There will be recordings made available, right? Eventually, I'd love to see, maybe take another look at the recording when it's out.
Yeah, and I'll drop a line in the chat for their company as well. But yeah, I believe so, that those will be posted. And then my question for you is if you could talk a little bit about your process or your company's process for understanding user needs and then really designing processes to meet that, because I think that's one of the things that the science community is really trying to get better at. And so a lot of the discussion here is how do we better align from the design phase of projects or monitoring programs all the way through to benefit. And my sense is that that's something that maybe companies, because their funding is dependent on meeting user needs, that they're a little better evolved to do. So yeah, I'm wondering if you could speak to that.
Yeah, I mean, understanding user needs is fundamental, right? Because especially for geospatial data where accuracy, so any few centimeters of accuracy improvement will cost you a lot more to implement normally for acquiring geodata. So it's really important to know, quite often, there's a problem that needs to be solved and the stakeholders don't know what data they need. So for us, it's really about having that open dialogue with our clients right in the beginning of the project, saying, okay, you think you need data of this accuracy. What problems are you actually trying to solve? Maybe you think you need very accurate data, but you could as well solve it with satellite data, which would be a lot cheaper. Or maybe you don't need to cover the entire scope or the entire area that you're thinking of, and maybe only, so it's really about having that dialogue right in the beginning with the clients and really getting to the bottom of the problem. And yeah, it's not easy because quite often, the initial conversations are done by a different part of the company, business developers or the sales staff who may not have that much of in-depth knowledge about the technologies. And by the time it reaches the technical staff, it's sort of, Chinese whispers along the way. So yes, these are more organizational hurdles than the practical side of things. But what we try to do as a company is really to have that upfront conversation right at the beginning, understand the problem that needs to be solved, and then frame, and no two projects are alike, right? Really frame the Geo-data program around the needs of that specific client and that specific question. I don't know if that sort of answers your question.
Yeah, I think it does. Yeah, I think it's something that as maybe the science community, we just need some more practice with.
Yeah. Okay, so we'll go Ravi, Harry, and then Sudan.
Thanks, Maribeth. Hi, Pooja. Thanks for that excellent presentation. You mentioned the importance of incentives to reduce the epistemic uncertainty. What specific incentives have you or FUGRO or WGIC offered to persons, I guess, from all sectors to share their data, which would work towards reducing the uncertainty and then result in better risk management?
So I think we as FUGRO are not really in a position to provide incentives to have what we try to do is lead by example.
Right.
So if we look at the case of what we're doing in CEBA 2030, what we're doing, with the UNESCO, it's really about leading by example, showing that there is value. It may not seem like it's an economic value for a company to just give away data for free or whatever. Mm-hmm. But for us, it's not a big deal. If we're collecting data anyway, if our ships are anyway in the oceans, it's just about turning on the machinery while we're transiting, or Right. So it's really a thought leadership. It's really about getting out there and leading by example. I think that's the best way I can put it.
I like that. Thanks, Pooja.
Pooja, I wonder if you could comment on the differences between trying to get data that's already been collected by private sector organizations versus encouraging private sector organizations to collect data that they're not already collecting. So, for example, just on the highways, there's obviously a number of different haulage companies go up and down, roads through Yukon, Alaska, and so on and so forth. They would, seems to me, make perfect vessels for sensors, but of course they're not doing that already. They'll need to be persuaded. So I wonder if there's a difference in approach between those two sort of groups. Yeah,
I think as big data becomes more the norm, I definitely see that, especially along the roadways. I mean, cars just get smarter and smarter, right? I think the average car you buy today collects way more data than a lot of these sensors that you see that you saw on the screen today. And I think over time that will become the norm. Crowdsourced data will become the norm. It'll be more a question of who's going to actually process and convert all of that data that's being acquired into something meaningful, something usable by an end user. Some of the technology that I talked about in the ARAN system, the automatic road analyzer system, is quite specific and quite heavy. You do need a truck to really carry that sort of equipment. If you need, we're talking about really crack level, micro crack level, details when it comes to road and pavement surfaces. That would be maybe a little bit too specialized for a normal car or a normal vehicle on the road. But yeah, it remains to be seen how much of that can be compensated by the bulk of data or the number of vehicles that actually go over the same road. That's really a research question to see how much of that data can be supplemented.
Thank you.
Yes, I want to ask about also this the use of data after you finish your campaigns. But when you plan the campaign, do you have in mind how this data set can be reused or eventually improved? Because you have a certain limited, let's say, scope of what you want to achieve, and then the data set is more useful. And do you plan it in a way that you can increase this use of the data also after your scope?
Yeah, absolutely. And we have a few examples of where so it's really about mapping once and using it many, many times. We try to do that as much as possible. I think in the white paper, I've given actually a fairly powerful example of how we used radar on a plane, so INSAR from a plane, to really map the digital elevation model of a part of Alaska. And then that's that was the intended application, but then there was like a whole lot of unintended applications that the data had from search and rescue, from a natural calamity that happened in the region, all the way onto measuring ice depth, which was more a research question that was actually surprisingly a side product that came out of the data. So as far as possible, we try to make our data available also for research purposes, unless our contracts with our clients forbid us from doing so. We try to make that data available and repurpose it as much as possible. So that's definitely our philosophy. If we can use it for multiple applications across the board, then we definitely do that.
So I actually have a question now. We're going to have a cross-cutting session with the data group, right? That just got me thinking, Pooja, about leading by example and trying to make the data accessible so it can be broadly used. And I'm wondering, I just want to put a pin in that for discussion with the data group, because I'm thinking like, the International Arctic Science Committee, and until the war, the Arctic Council has adopted a policy of free and open access to data and information, with the exception of sensitive data. And sensitive data, I think, is generally considered to be forms of indigenous knowledge, and maybe some stuff that might be militarily sensitive. I think it'd be good to have a discussion in our data group about the role of the private sector and how private sector feels about sharing data, and what the scientific community can do to encourage them. Because I know in the case of the work that Ravi and I have been doing with a few others on the shipping, we got data from the insurance company on shipping incidents, but it cost a lot of money. Not a lot of money in the private sector world, but in the academic world, it costs a lot of money. We ended up splitting the cost of that data set between a couple of different institutions, and then there was only a very limited amount of time we were actually allowed to access it and use it. So I'd be interested in what you think about some of those problems now, but I also like to revisit that maybe with the data group if it's appropriate at the time.
Yeah, sounds good.
So I guess that just leads me to, when you make data available publicly, it's available forever. Yeah. Is that correct? Yeah.
Yeah. Okay. Yeah. So it's not time limited or anything like that, and it's available to everybody. Yeah. And we normally channel it through, the likes of NOAA or bodies who can also amalgamate it together with their existing body of publicly available data.
Okay, Lucy.
So it was just to say that we're very fortunate. The presentation that I made yesterday and about some of the work that we're doing, we're preparing a pilot as a follow-on from the Pathfinder I described. And we're very lucky that Pooja and I have a mutual colleague who is helping us with that, to put some visualization on some of that story. But the point of that pilot is it's escalating well, because we have an audience of policymakers and insurance policymakers who have become even more interested in this different concept of actually dealing with people at this level, but actually having something beautiful to show for it. And it's turning their heads at the moment. So I just wanted to add that, we're really grateful for FUGRO to elevate our story in that way, but also it enables some people that wouldn't normally connect with it to be able to do that, and because it's so fascinating and interesting. But pulling all those behavioral change and how we communicate climate change methods that I talked about yesterday, and I just think it's really important and exciting. Thank you.
Yeah, thanks.
Pooja, yeah, I was just had a question related to the local communities. I was wondering if during your operations at FUGRO you were involving local communities for some measurements, or
most of the technologies I showed are actually remote sensing technologies. You don't require really to be boots on the ground unless you're talking about the CPT kind of tests. I think for the CPT kind of, yeah, of course, we use local resources. I think there's a lot of value in indigenous knowledge. I think nobody knows the Arctic, also from a geospatial sense, better than the indigenous population. I read a very interesting article recently about how, yeah, I think there was a really comparison between geospatial data and indigenous knowledge, and how that marriage can really improve the quality of climatic models in the region. And I think that is a direction I would really like to also look into myself as we continue this, acquiring more data and geospatial intelligence in the Arctic, how we can really get the most of both the worlds, the modern technologies and the indigenous knowledge in the most effective way. Definitely a topic of interest, both for me personally, but also I think from a quality of product perspective.
Thanks.